Hello there and welcome to a brand new lesson. This is Hap Beyond Numbers, where we learn maths the easy way. In this lesson, you are looking at the area enclosed by graphs. At the end of this lesson, you should be able to find the point of intersection of two or more lines by solving simultaneously. You should be able to identify the geometric shape formed by intersecting lines. Be able to calculate the area of triangles and quadrilaterals from vertex coordinates. Be able to use the shoelace formula to find the area of any polygon given its vertices, and then finally be able to solve problems involving areas enclosed by a linear graph and the coordinate axis. Here are some vocabularies we will be using as we proceed in this lesson, and I do advise that you pause and quickly take a glance. Now, prior to this lesson, I explained how to derive the shoelace formula. If you haven't looked at that, you can quickly look at that before coming to this lesson so that it will enhance your understanding. Without much ado, let's quickly look into it. So, as we all know, there are so many polygons. We have triangle, then the quadrilateral, then pentagon, and then it goes on and on and on. Now, for each of these polygons, or for some of them at least, there are specific formulas we use to find their areas. So for instance, if you take a triangle, you can find its area by multiplying the length of its base times half of the height, or half the base times height, right? So for the area of a triangle, it is simply 1/2, then times the base, then times the height. You see, then when it comes to a trapezium, it is what the area of a trapezium is 1/2, then the sum of the parallel sides, then times the height. You see, but then when it comes to other polygons, we try and then decompose them. By decomposition, I simply mean we divide them into the smaller ones. We can easily determine their areas. Then we now add to get the whole area of the polygon. It is the same when it comes to graph work. When you have a triangle and you can easily identify the height and then the base, you can use a formula to calculate it. If you have a trapezium, you can also use the formula. If you have a square, you can use the formula, and same applies to all the quadrilateral. That is, if you have the formula. But when it comes to the other complicated polygons, there is no easy way you can do that. You see, even if you try, you'd end up getting smaller squares that you'd need to find their areas as well. For instance, if you are to take this we have over here, there are smaller squares we have. So if you have to calculate the area of this square, and then you also come and calculate the area of this, now you realize that there will be others that wouldn't be complete squares, so it will be very difficult. Hence the shoelace method. The shoelace method actually works for all the polygons, even including the triangle, the trapezium, and then all the quadrilaterals and other polygons. Now the formula is as illustrated here, and as I said in our previous lesson, we went through the proof. But then let's take a triangle with vertices x1, y1, x2, y2, and then x3, y3. Now take note that, as I said earlier on, the shoelace formula doesn't only work for triangles or trapezium, but then for all polygons. But then we are using the triangle as a base case. So we have 3 vertices, that is x1, x2, and x3. To derive this formula, rather than memorizing, you can simply rewrite your coordinates. So if there are 3 of them, then we are going to write x1, and then your y1 here, then x2, your y2, x3, y3, and then we come again to x1 and then y1. So whatever I used to start, you end with that. So if there were 3 vertices, then you need 4 of these. If there are 5, then you are going to write 6. If there's 6, you are going to need what? 7. The reason being that you are always going to end with the first one. You see, if you are able to do that, then all you need to do is to do your multiplication. And by multiplication, this is what we do. So you just join these, and then in the reverse order, you also go this way as well. So by so doing, we say for the shoelace formula, we call it shoelace actually because of how this thing looks like. You see, if you are lacing your shoe, this is the pattern you form. All right. So we say the area of any polygon at all, that is area, is equal to 1/2, then the absolute value. We use absolute value because area can never be negative, you see. So the absolute value of, so following this direction, we have x1 times y2. So we have x1, y2, then plus x2 times y3. So x2 times y3, then plus x3 times y1. So x3 times y1. If you are done with all these plus, if you are now going to do those in the blue lines, that is the reverse order, it is now going to be a minus. So minus into bracket. So we rather want to be consistent, so we'll use y1 times x2. So we have y1, then x2, plus y2 times x3. So y2 x3, then plus y3 times x1. So y3 x1. You see, that is all. This is what we call the shoelace formula. This is the formula in its base form. But in order to rather be able to work it without memorizing, this is a very, very simple way. If you are given your coordinates, write them out as I have done here, and then you'd do your shoelace and then quickly do your multiplication. You realize that if you are to expand what we have here, you'd get the same thing. So x1 times y2, that gives us this. Then x1 times y3, that is x1 y3, or y3 x1. That is what we have here because it is negative, you see. So you can set yourself and try expanding all of this, and you realize that you are going to get this over here. So now that the formulas have been presented to you, let's then look at how we can apply it to solve questions. So we have our 5 steps process here, that is finding the area. So first of all, if we want to find the area bounded by the various lines that forms the polygon, find all the intersection points by solving the pair of equations simultaneously. You see, you wouldn't always be given the coordinates, but then sometimes you are given the equations of the lines. So if we have the equation of this line and then the equation of this line, this is where they both meet. If you have not been given this coordinate here, then you'd have to solve them simultaneously to get this coordinate. You include the x-axis intercept, and then also include the y-axis intercept as well. Now, if you're able to do that, you'd be able to tell if the line touches it. So for instance, if we take this triangle, you see it touches our x-axis. So if you were to find the x-intercept, we'll get to this point and then this point, and we'll go our way. But for this particular one, it doesn't even touch the x-axis. It rather touches the y-axis, you see. So you try for both to get, we are doing that so that we actually get the coordinates of the points, you see. So this intercept and then this one would have given us the 3 points to solve our equation. Then if we are able to do that, we now plot the vertices and then identify the shape. Then we apply the appropriate formula. So if it is a triangle and you think you can easily determine the height, fine. But if you want to use the shoelace, then you also use that as well. And you don't forget your unit. So whatever unit you are working in, because you are working for area, the formula is going to be the units squared. So with all this said, let's quickly solve some examples. So with our first question here, it says you have to find the area of the triangle enclosed by x plus y equals 8 in the coordinate axis. This is all we have. Now, you see, this is just one equation, so there is nothing like solving simultaneously. So we quickly go toward step 2. So our equation is giving us x plus y is equal to 8. So we want to look for the x-intercept and then the y-intercept. So finding for the intercept, we know that at the y-intercept, the value of x is 0. So we say at y-intercept, x is equal to 0. So this simply implies that we have a 0 plus y, which is equal to 8. Hence, our y is equal to 8. And that gives us our first point. So then our first point is going to be what? 0, 8. This here is the y-intercept. Then we look at the x-intercept. So we know at our x-intercept, what happens? The value of y is also equal to 0. So that is to say, x plus 0 is equal to 8. And our x is equal to what? 8. And that also gives us another coordinate. So we have what? 8, 0. At least these are the 2 points we have. So let's quickly go to our Cartesian plane, draw it, and then we determine whether or not we can get other points in addition. So this is my Cartesian plane, and I know my intercept. So on my y-axis, my intercept is 0, 8. And then on x-axis, it is also a 0, 8. So I'll just draw my straight line through these points. Now we know when it comes to drawing lines, we need at least 2 points, you see. So with our intercept 0, 8, then 8, 0, I'm just going to draw the line from this point all the way down to this particular point. So we can just extend it as well. Now we have our line, but then what polygon do we even have? If you come back to the question, say you should find the area of a triangle, and the triangle is enclosed by this line which we have drawn over here and the coordinate axis. So by the coordinate axis, then if we are actually forming a triangle, these are the remaining lines that it's talking about. So this and this is the triangle that is being spoken of. So now that we have our triangle, let's identify all our coordinates. So the coordinate here was what? 0, 8. And that here was also 8, 0. Now where would our last point be? It will be here, the origin. You see, we said coordinate, or the vertex of a coordinate, the vertex of a polygon is simply where 2 lines meet. So this vertical and horizontal line meet here, which is the 0, 0. So we now look at how to solve for our area. Now there will be no need using the shoelace method. Why? Because this is a very simple triangle with a height and then a base. So we can quickly go with that formula. Now, since I have my unit here, I'm saying every 1 centimeter is to 1 unit. So if I want to look at this over here, then I would simply say from this point to this point is actually 8 units or 8 centimeters. And then from this point also to this point becomes what? 8 units or 8 centimeters. So all we are then going to say is we know the area is equal to 1 over 2 times the height, then times the what? The base. That is of a triangle. And from what we've done here, our height is equal to 8. So from here to here, 8. And then our base length is equal to what? Also 8. So it simply implies the area is equal to 1 over 2 then times 8 times 8. 1 over 2 times 8 gives us a 4. 4 times 8 will then give us a 32. So 32 square what units. Right, but if I'm to stick to my unit over here, then I'm going to say 32 centimeter squared. You see, so that is that. In this first example, you see we didn't even need the shoelace method. Let's look at our second example. So in our second question here, it says you have to find the area of the triangle with vertices. A is what? 1, 2, B is 5, 2, and then C 3, 7. We want the area of this triangle. So once again, we can go to the graph, plot it out, and then we determine the height and then the base. But let's try with the shoelace method and then see. So for the shoelace method, there are 3 points here. So A was what? 1, 2, and then that of B was 5, 2, and then C was also 3, 7. So if we have to rewrite it just as I said so that we can be able to pick out our numbers, we have 1, 2, 5, 2, 3, and then 7. So with that, we know how it goes. And take note, we said you'd end with the first one again. So it means this 1, 2 is supposed to come here as well. So we start and then end with the first one. After which we do our multiplication. So this multiplies this in that order. And then we also come to the reverse order. For the reverse order is actually like this. So using that logic, then we are going to say the area of the triangle in question is going to be 1 over 2. Then we have 1 times 2. So 1 times 2 plus 5 times 7. So 5 times 7. Then plus 3 times 2. 3 times 2. After which we bring our minus. So minus everything that follows. So into bracket 2 times 5. So 2 times 5. Then plus 2 times 3. 2 times 3. Then plus 7 times 1. So 7 times 1. Let's do our simplification. So our area is equal to 1 over 2. Then we have 2 times 1, which gives us a 2. So we have 2 plus 35 plus 6. Then minus 2 times 5 gives us a 10. So 10 plus 2, 3, 6. Then plus 7, 1, 7. Area is then equal to 1 over 2. Then we want the absolute value of 36 plus 2 gives us a 37. 37 plus 6 gives us a 43. So 43 minus 10 plus 6 gives us a 16. Then 16 plus 7 on the other hand also gives us a 23. So minus 23. Which means we have what? Our area being equal to 1 over 2. 23 minus 43 minus 23 gives us a 20. Then half of 20 is simply what? A 10. Easy. So it simply means our area is 10 square units. As simple as that. You see how we're able to just use the formula to get our answer. if we were to do it graphically, then we would have plotted all these points on our graph, determine the height, and then determine the base. Let's do that here and then see how that is also going to be. So on our Cartesian plane, we are going to plot our points. The first one being 1, 2. So 1, 2 is going to be, so x is 1 and then y is 2. That is around here. Then our second point is what? 5, 2. So x is 5. At 5, we move up by 2 units. That is also going to be right here. And then the last point being 3, 7. So the same way we come to x being 3 and we move up by 7. So this is what we have here. Now since it is a triangle, then we should join these so that we would get the triangle, the picture. So with that, I'm just going to join this line, this point to this point, and then to this one as well to form my triangle. So all we need is the area bounded by this. Now, since it is a triangle, we can always look at it and then determine the height of the triangle. Now, from the looks of it, then it simply means from this side to this side is going to be our height, and also from this side to this is going to be our base. You see, and how do we get these? We just use the coordinates. By the coordinates, we actually already have them. So the coordinate of this, that is the 7 and then the 2. So for the height, we are going to use the y coordinates. That is the 7 and then the 2. And then for the base or the width, we are going to use the corresponding x coordinate. So with that, if we want the height, then it's going to be a 7 minus 2. You see, so our height is simply a 7 minus 2. So h, which is our height, is simply what? 7 minus 2. And that is equal to a 5. Then for the base, it is going to be a 5 minus. So b is going to be 5 minus 1, which is also a 4. So once again, the area of a triangle is simply half the product of what? The base times half the product of the base and then the height. And that is 1 over 2. The base is what? 4. So times 4, then times the height, which we have it to what? 5. And that gives us a 1 over 2 times 20, which is simply what? A 10 square units or unit squared. And which is the same as what we had over here. So that confirms that irrespective of the method you use, you are always going to get the same answer. This was a triangle and we have the formula of the area of a triangle. But as I said, when it comes to the more complicated polygons, then we are going to be forced to stick to the shoelace method. It is advisable you understand it, then know how to work with it as well. With that said, let's look at our third question. It says find the area of the triangle enclosed by y equals 2x, y equals negative x plus 9, and the x-axis. Once again, this is a triangle. There are two methods. I would only do that of the shoelace, and then I'll advise you also do it on the graph. Now there are three equations here. We have y equals 2x, that is equation 1. We have y, so let me just label them. That is equation 1. Then we have y equals negative x plus 9. That is equation 2. And then the x-axis. The x-axis written in equation form is simply the line y is equal to 0. So this is our equation what? 3. So you want to actually solve these three equations simultaneously to be able to determine the vertices of the triangle. Let's start with equation 1 and equation 2. So solving for equation 1 and equation 2, we know from equation 1 that y is equal to 2x. And we also know from equation 2 that this same y is equal to negative x plus 9. If this is y and this is y, then we can say y is equal to what? Y. And it simply implies that this y here, which is 2x, is equal to what we have here, negative x plus 9. Making x the subject, you have 2x, then this negative x comes to the other side to give us what? 2x plus x, which is a 3x. So we have 3x is equal to 9. Hence our x is equal to what? 3. So now that we have our x, you substitute it into any of the equations. So let's say put x into equation 1. If you put x into equation 1, it simply means our y is equal to what? 2x becomes y equals, the x is now a 3. So we have 2 times 3, which says our y is equal to 6. So that is to say, equation 1 and equation 2 have a point of intersection. And that point of intersection is simply what? 3, 6. You see? So we have equation 1 and then 3 meeting as what? 3, 6. So we do have where this and this meets. Now let's determine where equation 1 and then equation 3 as well meets. That is to say, we want where equation 2 touches the x-axis. To solve it for equation 1 and 3, we simply have the equations as y equals 2x and then y is equal to 0. So it simply means our 2x is equal to what? 0. This is only possible if x is equal to 0. So we have our next point. So our next point is what? 0, 0. So it means equation 1 touches the x-axis at the origin, that is 0, 0. Now let's look at our last one. So solving for equation 2 and 3, we know equation 2 was what? Y equals negative x plus 9. And that of 3 is y equals what? 0. So it simply means we have 0 being equal to negative x plus 9. Making our x the subject, we have our x being equal to 9. So this implies the coordinates we have here is what? 9, and then y is what? 0. So with this, we do have all our points to be able to solve. Now with these points, it will be very, very easy if you go straight to the graph and then determine your height and then the base. But on the other hand, using the shoelace method, so you would do that on your graph and then confirm from me if you have the same answer in the comment section. So using our shoelace method, our points we have 3 and then 6, we have 0, 0, we have 9, 0. Then since I started with it, I'll have to end with it as well, so that we have 3 and then 6. See, so our area is simply going to be 1 over 2, then the absolute value of, so we go this way first, 3 times 0. 3 times 0 gives us 0, so there would even be no need writing. 0 times 0 gives us 0 as well. Then we have 9 times 6, which gives us a 54. So we are done with this side. So we have this and then this and this. These ones give us 0. So 54 minus Then we have 6 times 0, it gives us 0. 0 times 9 also gives us 0. And then a 0 times 3 also gives us 0. So it will be minus 0. That actually gives us nothing. So our area is simply the half of this guy here, which is what? 27. So 27 square units. Now, if you used the graph, you would have been able to also determine the base to be 9 centimeters, 9 units, and then the height to be 6 units. And then half times 9 times 6 would have also given you a 27. Very simple, isn't it? Okay. So, with that said, let's solve our last question for this session. And I do hope it will help in your comprehension. So now for this last question, it says you have to find the area of the quadrilateral enclosed by, so you have two equations. The first one being y equals x plus 2. Then the second one being y equals negative x plus 8. Then we have x equals 1 and then x equals 5. So for this type of question, we can solve using simultaneous equation and then the graph. But I would always advise you go for the graph because the graph will be very, very simple. To solve it graphically, we need to get this line and then this line as well. These ones are very, very simple to get on the graph. So for the first one, we have y equals x plus 2. So we'll have to look for the x-intercept and then the y-intercept. So you see, at x is equal to 0, that is the y-intercept, then we have y being equal to what? 0 plus 2. And that gives us y is equal to what? Is equal to 2. So that implies y-intercept is what? 0, 2. Then we then look for our x-intercept. Our x-intercept says at y is equal to 0, we have 0 which is equal to x plus 2. Making x the subject, we have x equals negative 2. And that also implies that our x-intercept is what? Negative 2, 0. Then we come to the next equation. That is negative x plus 8 is equal to y. So use the same procedure. You see, at x equals 0, then our y is simply negative 0 plus 8. And our y is equal to 8. So that simply implies that the point is what? X is 0. So 0, 8. Then with that same line, we see at y is equal to 0. Then we have 0 being equal to a negative x plus 8. Making our x the subject, we have x being equal to 8. And that is to say our point is what? 8, 0. So we have these 2 points for this equation, and we can then draw this line. And we have the same also for this as well. So let's go to our graph and then see how we can transfer this. So this is my Cartesian plane, and we have 0, 2. So x is 0, y is 2. That is simply going to be this point over here. And then we have negative 2, 0. Negative 2, 0. So because of our negative, then I would have to include a negative domain. So this is going to be our Cartesian plane, and we are to identify all these points on it so that we can draw our line. The first one being 0, 2. So x is 0, y is 2. This is the point over here. Then the next one being what? Negative 2, 0. So negative 2, 0 is also over here. So all we need to do is to draw a straight line through these 2 points. So this is going to be my straight line. Now draw it this way. So I'll just extend this side of the line as well. Very, very nice. So with that line drawn, let's look at the next one. So for the next one, we have 0, 8. So x is 0, y is 8. This is that point over here. And then we have 8, 0. So 8, 0 is also around here. So we join these two with the line as well. So this is it over here. This is my line. And then I will just extend this as well. Okay. So now that we have these two lines, let's look at the ones that follow as well. So we have x equals 1. The line x equals 1. The line x equals 1 is simply a parallel line that passes through this. So we are just, this is R1. We are just going to draw a straight line through 1. Then we have the next line, which is x equals 5. X equals 5. So this is where we have our 5. We draw a straight line this way. So now that you have all of this, we now want to identify where the quadrilateral is. You see, so the quadrilateral in question, if you take this blue line and compare it to the white line, or if you are taking both lines, let's look at these white lines. Where do they intersect with them? So for the very first one, we have a point over here. We also have another point over here. We have another point here, and then another point over here. These are the vertices that we want to focus on. You see, so I'm going to draw straight lines to touch all of these. So from here all the way to here, and then we have this as well. You see, so in simple terms, I would have to just clean these ones. So we'll just have to clean all of this so that we actually see the quadrilateral. This is the quadrilateral that we are talking about. Okay, so all the construction we did, this was where it led us to. And we know the coordinates of all of this. So this one here has coordinates 5, 3. And this also has 5, 7. This one, on the other hand, is a 1, 3. And we have this being a 1, 7. So these are the points we want to use to find the area enclosed by this figure. Now you could easily, since it looks like a square, right? So you can easily find the length and then go your way. That is to say, if you want this length here, then we focus on the y. 7 minus 3 gives us a 4. So this would have been a 4. Then for this, we focus on the x. 1 minus 5 would also give us a 4. Now, for this one, to confirm that is equal to this, we have 7 minus 3, which is also a 4. And then 1 minus 5, which is, we want the absolute value. So 4. Hence, the area is just going to be what? 4 squared, which is a 16 squared units. You see, but if we wanted to actually use the shoelace method, then we have all our points. Let's see how we can actually use the shoelace method. So using the shoelace, our coordinates are 1, 7. So we have 1, 7. We have 5, 7. So 1, 7, 5, 7, 5, 3, and then 1, 3. And I would have to repeat this first one as well. So 1, 7. So let me just create space between them. And we know how the multiplication goes. So we just multiply these. And then when we finish, we also do same to this direction as well. So then our area, A is going to be equal to 1 over 2, then the absolute value of 1 times 7. 1 times 7 gives us a 7. So 7 plus 5 times 3, we have a 15, plus 5 times 3, we have another 15, plus 1 times 7, which is another 7. Then minus 7 times 5. 7 times 5 gives us a 35, plus 7 times 5, we have a 35, plus 3 times 1, we have a 3, then plus a 3 times 1 again, we have another 3. So our area is equal to 1 over 2, then the absolute value of, so evaluating this, we have 7 plus 15 plus 15 plus 7. That gives us a 44. Then minus 35 plus 35, we have 70. 70 plus 3 gives us a 76. So we have 76. You see? So we have A being equal to 1 over 2. Then this one gives us a negative 32. But take note, it is the absolute value we want. So we don't work with the negative. Hence, we simply say the area is equal to 1 over 2, then times the absolute value of 32 is what? 32. When we evaluate this, let me just write here. So when we evaluate this, we are going to get our area being equal to 1 over 2 times 32, which gives us a 16, which is the same as what we had over here. So 16 unit squared or square units. Very, very simple. So whether you understand what you are doing on the graph and then you find the length and evaluate, or you want to use the shoelace method, they would all work. But once again, our advice, use the shoelace method, because it is not always that it is going to be just a rectangle so that you can easily solve, or a square so that you can easily solve. For complicated polygons, it is best you understand and utilize the shoelace method. So that ends our examples for this lesson. As usual, I'll leave you with some exercises so you try on your own. So here are 5 questions you can try on your own on this topic. If there's any issue of concern, you can always let me know at the comment section. If this is your first time on this channel, you don't think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified and then learn along. This is Hard Beyond Numbers, where we learn maths the easy way. See you in our next lesson. Bye for now and do stay safe.